In this video, we're going to cover cumulative frequency plot. Let's say that you are the owner of a chocolate bar factory. And every time your factory makes a chocolate bar, you record the weight of that chocolate bar in grams. So up here, we have the weights of a few different chocolate bars. And from that data, we know how to draw a histogram. So let's draw a histogram of the weights of our chocolate bars. Okay, so we have the x-axis here, and on the x-axis we're going to plot weight. And on the y-axis, we are going to put number of chocolate bars. Okay, let's add a little more space there. Okay, so number of bars, let's start at 0, then we go 1, 2, 3, 4, 5, and then under weight, we go from starting at 90, so 90, 91, 92, 93, 94, and 95. So, okay, let's first look at chocolate bars that weigh 90 grams. So we have one bar. Okay, so then at 91 grams, we have 1, 2, 3, 4 bars. Okay, then 92, we have 1, 2 bars. At 93, we again have 2 bars. 94, we don't have any bars. And 95, we have 1 bar. Okay, so this is a histogram. And it tells us at every weight how many chocolate bars we have at that weight. Okay, so now I want to draw something different called a cumulative frequency plot. So let's draw a different graph. Okay, so I'm going to go through drawing a cumulative frequency plot, and I think you'll get the idea pretty quickly. Okay, so again, on the y-axis, we're going to put number of bars. And let's start at 0. And let's go, we're going to count by 2. You'll see why in a minute. 2, 4, 6, 8, 10. Okay, and then on the x-axis, we're going to have the same as before, weight. So 90, 91, 92, 93, 94, 95. So this is going to be weight. Okay, so at 90, we're going to plot how many bars weigh 90 grams or less. So we don't have any bars that weigh less. So let's put a bar at 1, because we have 1 bar at 90 grams. Actually, let's not put a bar. Let's put a dot. One dot here. Okay. Then at 91, we have 4 bars at 91 grams and 1 bar at 90 grams. So there are 5 bars that weigh 91 grams or less. At 92, we have 2 additional grams, so that puts us at 7. Then at 93, we have another 2 grams, not 2 grams, another 2 bars, so that puts us at 9. At 94, we don't have any additional bars, So we stay at 9, and then at 95, we have one additional bar, so we move up to 10 total bars. Okay, so let's connect those dots. Oops. Make sure those lines connect. And that is a cumulative frequency plot. So why did we just do that? Well, a cumulative frequency plot can give us some different information than a histogram. For example, let's say that I cannot sell any chocolate bar that is less than 93 grams in weight. So then I know that there are 7 bars that are 92 grams or less. So that means there are 7 bars I cannot sell. And I can read that directly from the graph. Another interesting feature of the cumulative frequency plot is its shape will tell you something about the shape of the histogram. So if we didn't have the histogram, we would still know that most of the bars were centered around the left portion of the histogram. So we have most of our bars around the left portion. So if we have most of the bars in the left portion, that means our histogram is what we called right skewed because there's a tail to the right. So we have a shape that's kind of like this. And we can know that the histogram is right skewed from simply looking at the cumulative frequency plot. The cumulative frequency plot is pretty much flat as we go to the right. And that means as we go to the right, there's less and less new bars being added. And we have a larger slope towards the left part of the graph. So that essentially means that we're adding all our bars in the left portion of the graph, and then we kind of have a tail in the right portion. So we know from this graph that our histogram is right skewed. So a kind of interesting thought experiment would be, well, what if our histogram wasn't skewed at all? What if our histogram was flat? Let's say our histogram looks something like this. What would our cumulative frequency plot look like? Well, you can think that the histogram is constantly adding points. So that means our cumulative frequency plot would just be a straight line. It keeps on increasing. Okay, well, what if our histogram, instead of being flat or right skewed, what if it was left skewed? Well, then our cumulative frequency plot, well, not much would be going on in the right, and it would increase as we got to the left part, but it would eventually flatten out. And always remember that a cumulative frequency plot can never go down. As long as we have only positive values in our histogram, we can never decrease in our cumulative frequency plot. So that summarizes cumulative frequency plots and gives a brief review on histograms.